Hi, we're going to take a look to our robot navigation avoidance obstacles that we have and that we base on the navigation 2D package. We copy the tutorial 1 launch file and copy the parameter files, that is the cost map, the operator, the Rush GML, and the RBs to take a look to the cost map that we have. The main objective of this program is to avoid the obstacles that are present. We have a terminal and that we can start launching the programs. The main launch file is the tutorial 1. That's the entry point of the node, well, to launch all the nodes and also launch another files. They are loading. Yeah, it will take some minutes, some seconds to start our programs, as we can see right there. We also can run with the Rust topic pop to start moving our robot to move, and if there is an obstacle, it should avoid the obstacle and change its direction. That's the main functionality of our project that we're going to have, and we can launch right there. It start moving, and we can just jump to our code that we have. For the code, the main changes are applied to the launch 1 file. There are the changes that we have, and right there we can see the differences. I'm going to use the editor to put it in constant what are the differences. The main difference is that we are not using the nav2d tutorials. That changes all to our self package, that is the robot navigation and my first name, that is Jesus. Instead of launching the stage simulator, we are launching an gazebo simulator, and the configuration, as you already seen, is the one with the walls. And well, right here our robot start moving and then start avoiding the obstacle, as it could be seen right here, that when it reach the wall, it can change its direction so it doesn't get in stuck. That's the idea of that configuration of the gazebo. We have after our empty world, we have the spawning, the simple robot, that is the one that you already seen, and then we are having an static transformation. The static transformation tells us that the baseline with respect of the baseline simulated are in the same place, and also they are looking to the same angle because they are all in zeros, the angular part and the linear one. We have then the measurements of our robot. This one is the width, the height, and also what is the tall, how tall is it. The operator, they are just referring to our self package. We remove the joystick because we don't require it, and also I don't have one connected. And finally we make a reference to our RBs program that is in our scope. So the reason of that is that we can have this configuration running our cost map. Then after we change the launch file, we can jump to the cost map file. For the cost map file, we calculate the radius of our robot, that is the smallest measurement that we have, divided by 2, and for the inflation radius, it is the outside circle that can be drawn. For the operator, we put more weight to our escape part. The reason that we put more weight to the escape part is due to we want that the robot start avoiding objects. That's the reason that we put it to 2, and we can put this value, that is the continuous line, to 0. More documentation can be seen here in the nav2 operator. As you can see, it is the safety weight, the distant weight, the conformance, the continuous weight. Here is our robot also working, drawing the cost map that we have inflated the obstacles. Just to mention, the objective of our RQ is to have this drawing. I forget to launch it, but I can launch it right here. Draws, run, and the architect graph. No, the draws, run, and the transformation tree. I want to see it. Where are the transformation tree? Yeah. Here is the transformation tree. We get the benefits that the simulator already provides of the odometer. We use just an static transformation to avoid getting, to avoid renaming many variables, and that's all that we have for our program.